You might be wondering how hackers attack in a cloud-based software system. This presentation is done by Pratiksha, Saurabh, Safal, Deepu and me. In today's digital world, almost everything we do, shopping, banking, communication and even storing a personal or business data, happens online. Most of this data is stored in a cloud-based system, making our lives more connected and efficient. But with the rapid shift to a cloud, one major challenge arises: cybersecurity. So what is cybersecurity? Cybersecurity is the practice of protecting system, network and data from digital attacks. These attacks, often carried out by hackers, aim to steal the sensitive information, disrupt services or cause a financial and reputational damage. Now you might be wondering, how does this relate to a cloud-based software system? Unlike traditional system where data is stored on a personal computer, cloud systems store data on a remote server accessible via the internet. This makes cloud computing powerful but also vulnerable to a cyber threats. If a cloud system is not properly secure, hacker can exploit weakness to gain access, steal data, or even take control of entire system. Cyber attacks in a cloud environment comes in many forms, including data breaches, ransom attacks, phishing, denial of service attacks. This can affect individuals, businesses, and even governments. In this presentation, we will explore the most common threats in cloud computing, real-world incidents, and strategy to enhance cloud security.
My name is Safal Thapa, and today I will be presenting the literature review on cybersecurity and cyber attacks in cloud-based software systems as part of our project. Cloud computing has revolutionized how businesses store and manage data, offering cost efficiency and scalability. However, it has also introduced new security challenges. This literature review examines recent research on key cybersecurity threats, common attack methods, and strategies to mitigate these risks. Cybersecurity challenges in cloud computing. Recent studies highlight various security concerns in cloud environments. Data breaches and privacy risks. Researchers emphasize that cloud-based systems are prime targets for cybercriminals due to the vast amount of sensitive data they store. Insider threats literature suggests that employees can be a big risk, either misusing access or accidentally leaking sensitive info. Insecure APIs. Cloud providers use APIs, but weak security can let attackers sneak in and access data. Moving forward to common cyber attacks in cloud environments, several recent studies focus on cyber attacks that frequently target cloud-based systems. DDoS attacks. Research highlights how modern DDoS attacks are becoming more sophisticated, using botnets and AI-driven automation. Man-in-the-middle attacks. Cybersecurity experts discuss how attackers intercept communication between users and cloud services, leading to data theft or alteration. Ransomware in the cloud. Recent findings indicate a rise in ransomware attacks where attackers encrypt cloud data and demand a ransom for decryption keys. Mitigation strategies in cloud security. Based on existing research, several security strategies have been proposed to protect cloud-based systems. Strong data encryption studies suggest encrypting data both in transit and at rest to prevent unauthorized access. Multi-factor authentication. Research supports the implementation of MFA as an effective way to prevent unauthorized logins. Blockchain for security. Emerging research explores blockchain technology as a solution for securing cloud transactions and authentication processes.
To continue here, I am Prastika, and today I will be covering the methodologies and findings of our topic. As we rely more on cloud services to store and access data, cyber threats are becoming more sophisticated. When we are talking about cloud system, we are really talking about a gold mine for cyber criminals. These platforms hold massive amount of sensitive data, making them the prime targets for a wide range of attacks. So we set out to answer a key question, that is, how can organizations better understand and defend against these evolving threats? To explore this, we conducted an extensive literature review and content analysis. We examined peer-reviewed journals, industry reports, and case studies recently published. Our research focused on analyzing cybersecurity framework, cyber resilience model, and real-world cyber attack scenarios. As a part of our study, we also reviewed real-world cyber incidents in cloud environments and examined widely adopted international security standards such as ISO 27001 and ISO 27017. So, what did we find? Credential theft, often through phishing and weak passwords, remain the most common methods attackers use to breach the cloud systems. We also discovered that Misconfigured cloud storage and inadequate data encryption are leading causes of data breaches. Other than this, denial of service attacks, especially the distributed ones, continue to be a major threat. These attacks disrupt the cloud service and can significantly impact the business operations. On a positive note, companies that adopt cyber resilience framework, including continuous threat monitoring and anomaly detection, are far better prepared to handle and recover from the incidents. Implementing multi-layered security, zero trust principle, and adhering to global security standards significantly reduces the risk exposure. So, these findings highlight the critical need for organizations to stay proactive in managing cloud security risks. As cyber threat continues to evolve, staying one step ahead of attackers is more important than ever.
The existing research on cloud security presents both strengths and weaknesses. Strengths include the development of novel cybersecurity models such as the cyber resilience framework and intrusion detection systems, which include cloud protection. Studies effectively address specific threats like DDoS attacks, cyber incident response, and cloud service vulnerabilities. However, weaknesses include the lack of comprehensive approaches that integrate multiple security layers, particularly virtualization and social media-driven threats. Some studies focus on isolated aspects such as DDoS prevention without considering broader systematic vulnerabilities. Additionally, existing solutions often lack real-world implementation and scalability evaluations. Let's explore the emergency security threats, security solutions, and research gaps in cloud security. Gaps in cloud security measures include insufficient cloud threat monitoring and incident response. Current detection systems fail to identify zero-day threats and persistent threats like advanced persistent threats. Security teams struggle to respond effectively to incidents due to lack of real-time threat intelligence. Inadequate DDoS protection. Current DDoS protection methods focus on volume-based attacks but does not sufficiently address protocol and application layer attacks. Attackers use botnets and zombie hosts to bypass rate-limiting protections. Limited threat protection and response. Existing cloud-based security systems lack real-time detection of emerging threats. Cybersecurity monitoring often fails to integrate adaptive machine learning models for better prediction and classification of threats. Inadequate cloud security monitoring. Cyber attacks such as man-in-the-middle, zombie attacks, and phishing are not effectively detected due to lack of continuous monitoring. Many cloud services lack automated security anomaly detection systems. Data security risk during transmission and storage. Encryption methods are not always robust, leading to risk of data breaches. Shared multi-tenant environments expose data to unauthorized access due to weak isolation mechanism. Let's discuss the potential improvement for the gap in current security measures. Implement AI-driven threat detection model to detect zero-day vulnerabilities. Develop cyber resilience strategies, including automated incident response and rapid recovery mechanism. Robust DDoS mitigation strategies. Deploy machine learning-based traffic analysis to detect and mitigate DDoS threats proactively. Enhanced threat detection mechanism. Integrate AI-based anomaly detection systems that utilize machine learning for threat classification. Implement real-time security event correlation to identify suspicious activity. Continuous security monitoring and threat intelligence integration. Utilize security information and event management system for real-time threat detection. Employ behavioral analytics to detect insider threat and unauthorized access attempts. Robust encryption and data protection. Use end-to-end encryption for data in transit and at rest. Now let's discuss about the possible future threats and evolving attack techniques. The future of cloud security faces increasing threats as cyber criminals leverage. The AI-driven cyber attack will enable real-time adaptation. Attacker will use deepfake social engineering to bypass identity verification by impersonating executives or employees. To counter these threats, organizations must adopt zero trust model, AI-driven threat detection, automated incident response.
Hello everyone, I am Saroj Kandel and I will be concluding our discussion by summarizing our key findings and exploring the future of cybersecurity in cloud-based software system. Throughout our research, we have identified several critical cybersecurity challenges that organizations face in cloud environments. Firstly, privacy concerns remain a major issue. Cloud providers have access to stored data, which make it vulnerable and unauthorized access or leaks. Second, unauthorized access to management interfaces. This can be exploited by attackers if not properly secured, leading to potential breaches. Third, data recovery vulnerabilities can expose residual data to unintended users, raising security concern about how cloud resources are decommissioned. Next, we have internet-based vulnerabilities like man-in-the-middle attacks. These highlight the need for stronger and more secure communication protocol. Finally, we explore emerging threats. Recent cloud security breaches, such as those affecting Microsoft Azure, emphasize the need for continuous improvements in security frameworks. What does the future hold for cybersecurity in cloud-based systems? While challenges persist, advancement in technology and cybersecurity challenges are paving the way for a more resilient cloud environment. To strengthen cloud security, organizations should focus on several key areas: enhanced privacy measures, implementing advanced encryption techniques and privacy policies to protect sensitive data, stronger access control, using multi-factor authentication and role-based access control to prevent unauthorized entry, data sanitization improvements, ensuring that deleted data is completely erased from cloud servers to prevent recovery by unintended users, proactive threat detection, using AI security tools to predict and prevent cyber attacks before they occur. In conclusion, cybersecurity in cloud-based systems is a dynamic and evolving challenge. As threats continue to emerge, it's crucial for organizations to stay ahead by adopting advanced security practices and continuously improving their defense mechanism. With a proactive approach, the cloud can remain a secure and reliable platform for businesses worldwide. Thank you for your attention, and I hope this presentation has provided valuable insight into this critical topic.